let's take a look at another CSES math problem. Stick game. So what's going on here? So we have a game. We have sticks in a heap. We're going to take turns making moves, and we want to remove the last stick. And so there's a set of moves that we're allowed to make. So for example, if we can move 1, 3, or 4, that means that on every turn we can either move 1, 3, or 4 sticks. And so we want to know, for every possible number of sticks from 1 to n, whether the first player is going to win with optimal play on both sides, or whether the second player will win. So that's what we're given. So for example, if the moves are 1, 3, and 4, so if there's 1 stick, then you win by taking it. If there's 2 sticks, then the only thing you can do is remove 1 stick, and then the second player gets to remove 1 stick and wins, so there's a loss for the first player. If there's 3 sticks, then you can just take them all and win. If there's 4 sticks, you can take them all and win. If there's 5 sticks, then you should take away 3 of them, and then the second player will be in the losing position of having 2 sticks. So that was 3, 4, 5. If there's 6 sticks, then you can take away 4 of them and put the second player into a losing position. If there's 7 sticks, there's actually nothing that you can do. Right, we can see if we take away 1, 3, or 4 sticks, it always leaves the second player in a winning position, so we've lost. If there's 8 sticks, then we can win by taking away 1 stick, leaving the second player in a losing position. If there's 9 sticks, again, no matter what we do, 1, 3, or 4, we leave the second player in a winning position, so 9 is actually a losing position. And 10 is winning because you can take away 1 stick to put the second player in the losing position of 9. So that's sort of how you can do the sample. How do you do it in general? Well, we kind of talked about it, right? It's a winning position if you can move into a losing position, right? A losing position for the other player. And if it's a losing position, if all of the possible moves lead to a winning position for the other player. And by the way, we should think of 0 as a losing position, because that means that the other player just won by taking the last stick. Right, so we could say that 1 is a winning position because you have a move of taking 1 stick into the losing position of 0. Yeah, so for every position, it's sort of like a DP, right? We're going to build up which positions are winning and losing, and then for every position, try all the possible moves, see if any of them lead to a losing position. If so, you win, otherwise you lose. So this is like 100 times 10 to the 6, which should be fast enough. So let's code it up. So what's the input? We have n and k, and then we have a vector of moves. Okay, so this will be whether or not each position is a win or a loss. And we want from 1 to n, so we should do n plus 1. So we want to check if any position, if any move leads to a losing position. So if I minus pj, right, if the move is legal, right, we can't go to negative sticks. W I minus pj is losing. Then it's a winning position. So that's it, actually. This is like the main thing, and then we just need to print out the answer. Well, I'm a little bit worried that printing out a million things might be too slow, depending on how it buffers, but I think it should be fine as long as we don't. Right? And if you print like a new line, I think that actually it does something, and otherwise it just sort of saves up the line, so it should be okay. So if it's a winning position, we print out W, otherwise we print out L, and at the end we print out a new line. And we're going to need the IO stream, we need vector std. it. No, that's not right. Zero. How did you come up with 0? J is less than K. Yes, okay. I should do that over the moves. Okay. LWL, WWWW, LW, and that should be up to N. Stuff. LWLW, and not 0. 1 to N. Cool. Okay, so it works. So yeah, it's just as we said, just as we do in the example. You want to find a move that takes you to a losing position, right? Losing for the other player. And if you can find such a move, then this is a winning position. And if you try them all and you don't find such a move, then, well, you go with the default of it's a losing position, right? So it's losing unless you can find a move that leads to a losing position. And then we just print it out. So that's the problem.